In Algebra 1, Section 9.3, we're dealing with exponential growth. Now, in this section, we have 4 different equations, but they all deal with increasing exponentially. So, exponential growth and exponential decay are, their equations are like this, except in growth, we have a plus r here. In decay, we have a minus r. And y equals the final amount, a the original amount, r the rate in decimal, and t is the time. Compound interest has to do with finances, and that happens, well, this has to do with finances too, but this happens when you have interest that's compounded every year. So then you have a new initial value every year. The a is the balance after t years, so you have this many years. P is your original amount, r is your rate in decimal, and n is the number of times compounded. So if it's yearly, it would be 1. If it's bi-yearly, it would be twice. If it's quarterly, it's 4, and so on and so forth. Half-life has to do with carbon dating, to figure out the life of things by comparing 2 different things using carbon dating. So A is the final amount, B is the original amount, and T is the number of half-lives in the given period. So you have 4 equations, and basically they're going to give you a question, and you're going to have to figure out which equation would best help you find your answer. So I need you to pause it and write this down, and then we'll go through an example problem. So this one, it says on number 1, the population of a town is decreasing. Sorry, let me fix this. The population of a town is decreasing at a rate of 3% per year. In 2000, there were 1,700 people. Write a function and find the population in 2012. So we're dealing with population of a town is decreasing. We're talking about exponential decay. So that's the equation we're going to be using. And exponential decay is y equals a 1 minus r to the t. Now, we need to break down each part before we can proceed. So it's asking us to write a function and find the population in 2012. So the population of a town is decreasing at a rate of 3%. Now, rate is r, and it's 3%, but if you look closely, the rate needs to be in decimal. And basically, I just take the percent and I divide it by 100, which should give me 0.03. Okay, in 2000, there were 1,700 people. So in 2000, so our initial amount, A, is 2,000, which means 1,700 people. Write a function and find the population in 2012. Now, if 2000 means this is our original year, this is 0. So 2012 would be how many years to 2000? Okay, so I wouldn't put 2012 in for time. I would put the difference between here and here is 12 years. So my t would be 12. So the equation would be y equals a, which is 1,700, 1 minus 0.03 t. This is our equation, and it just matters on what time they're looking for us to find the final population. So in this case, they wanted us to find in 2012, so we found that it's t is 12. So we're going to plug it in. We're going to have y equals 1,700, 1 minus 0.03, which is 0.90. To the 12. So just like when we're dealing with the order of operations, powers go first. So it might be tempting to multiply these together, but first I have to do 0.97 to the power of 12. And that's 1,700 times 0.69384. and then I can multiply these together. So I have to do first the power. So this is first, okay? Which is 1,000. This is rounded, because I can't have point something of people. So it would be 80 people. Now if this was pounds, I can have point something pounds, but it would be kind of mean to ask for, you know, because it says 1,179.53. I can't have 0.5 of a person. So I have to round up. And that's my answer. So again, it's just matters of which of the four equations you're going to use, plug in what you know to find out what you don't know. It's not always like this one we're lucky to find y, but they're not always going to be y. Sometimes they'll give us y and we have to find t, or we have to find r. So pay attention to what it's giving you and what it's asking for. Try page 639, number 5, 639, number 5, and I will see you in class.